what I want to talk about is messing with time. Um, Now, I guess the first thing is my name is quite easy to find if you've not come across me through Build Stuff. I have an internet unique name. That's my Twitter handle. I've got a kind of long background in a variety of programming languages, coming through the patterns community, interest in software architecture. A few years ago, I edited book 97 Things Every Programmer Should Know, and currently this week we're finishing off the edits to 97 Things Every Java Programmer Should Know, which I've co-edited with Trisha G, and that should be out in June. So you have something to read when we all get let out from lockdown. You'll be able to sit there in the sunshine and read 97 Things Every Java Programmer Should Know, which is a crowdsourced book. Interestingly enough, there are about 2 or 3 items in 97 Things Every Java Programmer Should Know that are actually about date and time handling. And that's what I want to talk about, is the fact that we make such a mess of it. Developers have a very poor relationship with time. As Melvin Conway observed in his classic paper from which we get the term Conway's Law in 1968, there's never enough time to do something right, but there's always enough time to do it over. The real issue here, though, is time. Date and time handling, date and time representation. I wrote a blog a while back, or relatively recently, where I made the observation that if you think you know enough about date time handling as a developer, if you think you know enough about date time handling to do it right, then you're probably wrong. If you think you don't know enough, you're probably right. It is always harder than people expect. And there are so many issues that people have in this context. So we can actually kind of see an example. This is an error message. I'm kind of well known for capturing error messages. In fact, people send them to me online. And the one here is the most interesting one. My license will apparently expire in over 2 billion days, which is obviously something I should be immediately worried about. And as developers, we should be able to see that number and look and go like, wait a minute, that's 2 to the power of 31 minus 1. That's a suspicious number. This is a 32-bit signed integer, and it's the maximum value of that integer. Clearly something horrible has gone wrong. We can also see this one. For some reason, I decided I'd submit some feedback to Facebook a few years ago because a feature was broken. And here's the response. Your feedback will be used to improve Facebook. It wasn't. Thanks for taking the time. The time is what we're talking about. But it's the date. That's the thing I want you to notice. The date here, 31st of December, 1969. I don't think Facebook existed. We're going to come back to this error a little bit later. But given that we're in the 1960s, given it's 1969, let's talk about the moon landings. Let's talk about some of this representational stuff. So this happened July 20th, 1969. This was Tranquility Base. This was the landing of Neil Armstrong, Buzz Aldrin, Apollo 11. And we can write it out, July 20th, 1969, or 20th of July, 1969. In English, it doesn't really make much difference. And in fact, there's no real problem with the ordering because, as you can tell, each word has its own type. So this is actually properly type checked. And we can even abbreviate the full year down to 2 digits of the year, 20th July, 69. More likely, we're going to write it like this, 20th of the 7th, 69. And then you've got people that will write it like this. That's just wrong, okay? But nonetheless, it reminds us why there is an Atlantic Ocean. You've got variations in punctuation. So Germany, it's much more common to use a dot than a slash. We can use the full year. We can pad out the year and put a 0 in there. Or we can actually use the one true date ordering. There is one ordering that is, of all the orderings, the one true date ordering is ISO 8601, which is kind of the international standard for layout and format. It's the one used by the web. It's used by all devices. Year, month, day, normally using a dash. This is the extended format. You can use the basic format, which also tells you, actually, this is why this is such a cool format. It always orders, and it orders perfectly. So anything in this format will lexicographically order. You can use the absolute full format that includes the time. So the moon landing was at time 8:17 in the evening. The Z stands for Zulu time. Basically, it's UTC or GMT, the meridian time. So this is another way of writing that time. So we have a standard way of doing this, but that's not the way that we actually work with it in our data structures. Perhaps the one you weren't expecting to see was this one. 20th of the 6th, 69. What's going on here? Well, this is actually how you do an initialization of the C TM structure. Now, this is where it's all going to get a bit technical. I'm going to spend a bit of time looking at C because it turns out that a lot of the really bad stuff that we get and mess up with date and time handling comes from this. But it also helps highlight how hard it is to design an API. So this is the structure that is used in the time header in C. A couple of things to note about it is like, well, it's got some redundancy. You've got this like TM underscore. That's really old C. It's like 1970. That basically back then, namespaces of structures were not unique. So you ended up, everything shared the same namespace. So you had to use this prefixing approach. If we want to initialize tranquility base, we could set it up like this, declare it, struct TM tranquility base. Then we get to initialize. Now, as you can tell, if we fill everything out that we're interested in, this is going to be a nightmare. This is so easy to get wrong. All you need to do is miss out one thing. They're all integers. There's no distinction. There's no ordering. You can accidentally end up forgetting that you're not initializing the right kind of field. We can skip the ones at the end because it does zero initialize. Sometimes people will write it like this. They will just do this and then just say, here are the things of interest, and then just initialize individually the fields. C99 lets us do that more easily, and zero initializes everything, so it's actually correct. We can actually make that constant, so it doesn't change. This is all good stuff, but I want to go back to this because this is where the problems start. Let's start with the first thing. It's called TM. What does it represent? It represents a date time. The name TM suggests time, but it's actually a date time, a calendar time. In that header, you have three things that relate to time. The naming does not make it really clear what name corresponds to what concepts. Already we have a problem. But honestly, I'm going to say it's nothing compared to the Java problem. Java has a class called date. I mean, it's mostly been heavily deprecated now and replaced by the Java time module. But what is apparently astonishing is how much of a mess the date class was at all, that it should never have even escaped Sun Microsystems as it was. I don't know, I can't recall anybody ever coming up with such a bad abstraction. Having been somebody who wrapped up all of the lower level facilities in the past, I can't imagine doing such a bad job. I think it would have been really difficult. The first thing is, it's got a class called date. What does date represent? Well, date is not a date. Date is a date time. So the first thing is the name is wrong. It suggests it's a date. A date represents a day. A date time represents a time in a date or a calendar time. So first of all, the name is wrong. Phil Carlton observed only two hard things in computer science: cache validation and naming things. So first of all, we're off to a very bad start. The next thing, let's have a look. The day of the month, that goes from 1 to 31. Let's go back to C. T, M day, month day. Yeah, that's kind of okay. The name's a little short, but it kind of clears itself out. Then we get the month since January. That's why the landing was apparently in month 6, not month 7. So the month since January, but the day of the month since 1. In other words, you've got two different conventions here. And then you've got the idea of now we're going to do the last 2 digits of the year. Actually, it turns out that's not it either. It turns out what we've got is year since 1900, which means today, using the C library, we are in the second day of the 3rd month in year 120. This is something people will always get wrong. It is so error prone. This is just a very bad piece of API design. It turns out that if you try and do this style of initialization, it's easy to get it wrong. You can do the American date ordering. You can start with the year 20. It's just a mess. So you think, right, this is just C. This was standardized in 1989. It dates back to 1970. And you think that's all the past. The problem is that this is API design in the simplest form. We can actually see day of the month since. You're using two different conventions here for something we already have an everyday convention for. You've got 0 counting and 1 counting, but you're not choosing one or the other. You're choosing both, which is kind of, never do that. Never give people two conventions and then choose both. Choose one and stick with it. This wouldn't necessarily be a problem, except for the fact that Java, which has nothing to do with C, decided that they would recreate this. If we look here, years since 1900, you get exactly the same mistake. Having had 25 years of experience with the errors in C and promoting Java as an object-oriented language, therefore higher level, easier to use, they made exactly the same mistakes. They made no effort in the design of this. But if you look closely, they even messed up the names. They actually got it worse than the C library, because if you look at that, get date, what's the class called? Date. Well, we've established that date is the wrong name for it. It's a date time. But logically speaking, if you've got something called get date, you'd expect it to get the thing that it's in. Date is an ambiguous word in English, just like 0 or 1 as two conventions. We can use date to either refer to the day in the month or a whole date. So in other words, it either refers to a part or the whole. And here they're playing fast and loose. They've decided to have one word and use it in two different ways, one of which is actually wrong. So if you wanted, you might say, well, why didn't they call it get day? They did have a get day, though. There is a get day. The problem is it doesn't mean day of the month, it means day of the week. Like I said, only two hard things in computer science. This leads to the next question. Let's go back to C, because this is exactly where it gets it from, where you can see the name is actually clearer. W day, it's not as good as weekday, but at least it tells you. Now we have the problem of which day is which is the first day of the week. Now, some conventions, Sunday is the first day of the week. In other conventions, Monday is the first day of the week. Now, if we switch to Lithuanian, which I'm not even going to attempt to pronounce, one of the great things about Lithuanian is it just numbers the days. And even if you don't speak Lithuanian, you can tell, because it's an Indo-European language. If you go and look at this one, that's kind of like primary, that this exists in many Indo-European languages. That means 1. It's like, oh, that looks like a 3, like penta, that looks like a 5. Yep, this looks like a 6. In some cases, that's going to look like a 7. In other words, you can tell the days are numbered. It's great. Day 1, day 2, day 3. Couldn't be easier. It's aligned with Monday as day 1. And you think, right, well, that's the end of the story. Problem is, I grew up also speaking Portuguese. And Portuguese has a slightly different approach. Domingo is Lord's Day, Sunday. Saturday is sábado, Sabbath. And then the rest of the weekdays are segunda, terça, day 2, 3, 4, 5, and 6. So you have two conventions, two of which are numbered. So what is it that C decided to do? Well, some people will be delighted to know that Monday is day 1. Other people will be disappointed to discover that Sunday is day 0. So we have another kind of interesting counting thing. So the way they rationalize this is days since Sunday. Okay, maybe we can get on with that. There's no surprises for hour. We can feel a little bit more comfortable. Okay, hour, that's good. There's no stupid 12-hour convention. There's no AM, PM flag or anything like that. And we can be comfortable that the minutes after the hour, that's 0 to 59, that's all good. Then we hit seconds. 0 to 60. 0 to 60. Okay, wait a minute. Hang on, shouldn't it be 0 to 59? No, there's leap seconds. Leap seconds, you can have at most 1 leap second per 6 months. And the designated days for leap seconds are the 30th of June and the 31st of December. In fact, we had one on the last New Year's Eve. We New Year was 1 second later in arriving than people expected. So therefore it goes 0 to 60. And leap seconds, those cannot be premeditated. That's to do with the vagaries of the Earth's orbit, and that's not something that can be anticipated like leap days. Some systems actually get around it by using a technique called leap smearing. Instead of actually having seconds go up to 60, what they do is they just drift over the whole day. They put a few milliseconds extra in each hour, just so that it never gets too far wrong, but you eventually stretch your 24 hours and 1 second over 24 hours. And it just works out just about right. But I love this whole idea of XKCD. Why not actually do this with leap days as well? Just spread them out over the whole year. But the story doesn't end there, because people make mistakes. This is what happens when you move between counting systems. People make mistakes. And if you go back to the original C standard, the ANSI C standard, it made a very small mistake. They went from 0 to 61 because somebody said we need to add 1 for leap seconds, forgetting they'd already added 1 for leap seconds. So they actually accommodated 2 leap seconds. That was fixed in the next C standard. Okay, so this is the point. People can basically get the stuff wrong. What about Y day? You can probably guess that that means the day and the year. And they got this one right for leap years. Days since 1st of January, we count from 0. So that means, by the way, that day 1 of the year is day 0 in this. People are going to get that wrong. But at least they have the right number. 366 days. This year has a leap day in it, so it can accommodate that correctly. So this is not a problem. Yeah, sadly it is. It turns out, in relatively recent history, Sweden had a February which had 30 days. This was in 1712, and Sweden had the most creative and most imaginative approach to trying to implement the Gregorian calendar. So basically, once upon a time, we all used the Julian calendar. The Julian calendar had a leap day every 4 days. Julian, named for Julius Caesar. This goes back a long way. It doesn't quite align the Earth, the days and the seasons quite right. The years start drifting, or rather the seasons start drifting. So 1582, the Gregorian calendar was introduced, but it was introduced very slowly. From 1582 up until, I think, 1925, countries slowly adopted it. So Turkey, I think, was the last country to officially go. In Russia, the October Revolution was not in October, according to the rest of the world, because they were still on the Julian calendar. And most countries would do this in a very simple way. Britain did it in 1752. It had 1st of September, 2nd of September, 14th of September. So they just adjusted their calendar like a big bang approach, nice and quickly. Sweden decided to do something different. They decided that they were going to adopt the calendar incrementally. Now, whilst in software we talk a lot about incremental development, it turns out this is not always the best approach. What they decided is they would avoid leap years for 40 years. So basically, they had from 1700 until 1740, they would just have 365 days every year. And so they did this in 1700. They didn't have a leap year. So they were 1 different from everybody else that was on Julian, and they were 10 different from everybody else that was on Gregorian. And then they started a war, and it turns out that during a war, the Great Northern War, during a war, you don't really want to be changing your calendar. So they decided to just have, go back to the usual leap day structure. This basically meant that they were wrong with respect to every calendar in the world except their own. In 1712, they said, no, let's just go back to Julian. And they did that. And they had 2 leap days in February. And you can see here, there we go. There's Februarius, and then 29, 30. So 30 days in February. They went back to the Julian, and then I think in 1753, they decided to do the Gregorian in one go. Fortunately, by the time it came to 1967, when Sweden decided to change sides of the road from driving on the left to driving on the right, they did not use this technique. They did it all at once, okay, over a weekend, a long weekend. They did not gradually move from the left and the right. So, yeah, the C standard gets this one wrong. Okay, now, here's a nice intuition. This one is DST. Is daylight savings time. Yeah, daylight savings time. So we've just switched to daylight savings just a few days ago. And so this looks really intuitive. And the naming really tells you very strongly that this is a Boolean. And traditionally, C did not have Booleans. It used integers. So perhaps that's what's going on here. Oh, that's fine. Okay. So logically speaking, you can go ahead and do this. If today, we are saving daylight. Yes, otherwise winter is coming. Okay. And that looks really good. There's only one problem with this. It's wrong. because actually it's not a Boolean. The name is Boolean, but it's not a Boolean. It turns out it has 3 different ranges. If it's positive, then it means it's daylight savings time. If it's 0, it means it's not daylight savings time. If it's less than 0, and -1 being the most typical example, it means actually we don't have the data available. This is unfortunate because if you write this code, it means you will mistake the error case, which is we have no idea whether or not we have daylight savings time. You will mistake the error case as having daylight savings time. And most of that just comes down to the name. The name itself suggests this is Boolean. So it's actually a 3-valued logic, which is kind of interesting because -1 and negatives, that raises the question. If we've got this, if I represent the exact time and then I print it, this works in C. It comes out correctly. Yeah, it was a Sunday, July 20th, 2017. Yeah, it's all good. What if we use the other time? The other time t. Now, time t, a lot of people think that time t is an integer that counts the number of days, is specified to count the number of days since 1970. That's actually not true. The C standard actually says it's not guaranteed, it's not specified, it's just an arithmetic type. The POSIX standard that's used on all Unix systems and Linux, number of seconds, that's the epoch time. So the number of seconds since the 1st of January 1970, that's what it counts. The question is, can it represent times before that? Mostly yes. And we can actually test this, and I certainly tested it on my machine. I can take that, I can convert that, and it turns out that this is how many seconds before the turn of the decade the moon landing was. So you think, okay, this is great. But you're left with a question. What happens if that function has to return an error code? Because this is a language that has no exceptions. What does it use? It uses -1, which is unfortunate because that means that -1 is actually now an error code and a valid value, which actually goes some distance to explain why it is that when I submitted a query to Facebook, they ended up on the 31st of December 1969, because at time -1 is 1 second before midnight that turns the new year of 1970. And that means it's 31st of December 1969. In other words, that's not a valid date. There was some error on the server that the time was not available, and they reported that rather than catching it as an error. Error handling is hard, even when you do have error handling mechanisms, but it's even harder when you have an API that kind of blurs the distinction. Now, with any luck, you're sitting there thinking like, okay, I'm prepared for the next thing, because if we go back to Java's date, you look at get time and you think, okay, I've got this, I understand. Clearly, get time here, based on everything that Kevlin said, is because Java follows C so closely, and because the naming is so similar, and because everybody thinks in terms of seconds since 1970, obviously get time returns you the number of seconds since the 1st of January 1970. Actually, it doesn't. It returns the number of milliseconds, which is a big surprise to a lot of people. So I'm going to kind of close this here because I don't want to bombard you with too much API stuff, and Felina's going to talk about more general stuff. But what I want to do is just get across to you this idea that is characterized by Anderson's law. I have yet to see any problem, however complicated, which when you looked at it in the right way did not become still more complicated. Date time handling is hard enough as it is. When you actually look at the logic without APIs, it's always harder. There are always exceptions. To every single rule, there is a surprise and an exception. And just when you think you've understood it, somebody will present you with another exception. And then we put into the mix careless API design. Now, of course, we can't get everything right first time, but there is this very simple idea of let us learn the mistakes of the past instead of repeating them. All right. Thank you very much. Do we have any questions? No, I think... when was this written? We already messed with time for event, by the way. But this was written when? 1970, yes, 1970. So this is from Justinus to everyone. Yeah, so all of this dates back to 1970. Unix started
I
being
might
written
comment a bit
in
regarding those.
1969.
I wrote
And
a bit earlier, so
oh,
that
yeah,
I was writing about maybe C class when you were discussing the C class. So I thought
yes.
it was maybe written in 1970s. That's why the date was there, and then the Java library. It was written later, of course, but then I guess they copy pasted the C library mostly.
The problem is if you copy paste the C library, it won't compile because it's Java.
Yeah, I know, but I mean by copy pasting, you know, you opened up the C library and you just rewrite it in Java, and pretty much
I
that.
find that a very unlikely story because if you look at the whole class, they don't do that. It's very clear because they didn't copy and paste. They changed the names, they added documentation. In other words, it's actually harder to just copy the one small piece, the one line, and then
Yeah, I
provide an
understand that it
explanation.
was not like the simple copy paste, but in general speaking, why would one do the same exact thing and you know, rethink it very hardly and etc. when you just can
Um,
look it up and, you know, make some additional enhancements etc. and that's it.
yeah, the problem is I don't believe that theory. I've had somebody else. I think probably if you look at it, if you look at Java's class for date, you will realize the one thing they can't have done is copy and paste or even just borrow the convention because it's harder to get that right than it is to implement it correctly according to everyday convention. In other words, you actually have to try harder to do it the way they did than to follow everybody's expectation. And all of the
Maybe I
people who
don't argue.
develop, sorry?
I said maybe I don't argue with that.
Yeah, the point is I will say this from a personal experience point of view. Um, it is harder to copy a bad convention and use the one that everybody's using. And when I say everybody, I mean everybody. Nobody uses months counting from zero. If you look on all of your, if you look on newspapers, websites, all of this stuff, if you print out Unix time, if you go to a Unix command and you print out what the date is, it will not show you that now is month 3. It will show you that now is month 4 and it's April. In other words, everybody uses the system that we're familiar with. So it's only this small quirk there. Everybody compensates for it. So they would have, put that in the Java library, they would have actually had to have put effort to avoid getting it right. So it's actually harder. And when you look at the rest of the class, you realize it's very inconsistent. And I think they thought they might be helping somebody, but I don't think that person exists. So yeah, copy and paste is not going to be the answer, or even just lazy copying of convention, because it's more work to document that. And it's certainly more work to deal with the handling. So I think it was just good old-fashioned bad API design, that somebody did not think that they should revise it. They thought we will be compatible with something that nobody wants to be compatible with. But I think that it was a mistaken idea of compatibility. That's what drove it. I don't think it was copy and paste. I think it was the idea we should be compatible with something. Yeah, does that make a little more sense?
Yeah, they were futuristic, maybe, pretty much.
Yeah, they were compatible with something, but they forgot to ask people, should we do this? Given that nothing else, let's put it this way. In Java, let me offer you a simple statement. In Java, strings are all based on bytes and they are all null terminated. Now, that would have been the easiest thing because that's how C does it. But they chose not to do that. So in other words, I don't understand where the design of date comes from because they did rename everything. So yeah, it's an interesting one. Any other thoughts or, why is JavaScript timestamp is millisecond based, not second based? It is because Java did so, because Java at that point, it was not because JavaScript could be millisecond precise. That was not really the issue. It's not just because Java was also millisecond precise. Around the 1980s and the early 90s, what you will find what you will find is that a lot of extended, in the Unix space, a lot of people were extending the traditional time facilities with millisecond features. So that was common, but not necessarily standardized. And in the early POSIX APIs around then, you will see the millisecond extras. They were extra functions for dealing with milliseconds. So millisecond precision was available. Now, although, as has been pointed out, Java is not related to JavaScript, some of the ideas in it were, and if you look at JavaScript date, that does borrow from Java's date. That one is a conceptual match. So in other words, in that sense, JavaScript is trying to be relatively conceptually compatible with Java. So yes, that's the interesting thing, is once somebody starts an API design, then everybody starts following it, even if there's no compatibility. And that's what I find absolutely fascinating. Here is a thing that was a careless thought in C in 1970, and nobody knew in 1970 that this would become popular. And then it propagates out. It propagates out until everybody's using it. We see it with other things like the spelling of the word clonable. If you look at .NET, .NET has an interface that is called clonable, well, the iClonable, and the clonable part is spelt in exactly the same way as Java's clonable. Java, unfortunately, spelt the word clonable incorrectly. Okay, so that spelling mistake has been propagated through to Microsoft, who copied the spelling. Even though there's no compatibility between the platforms, they took the spelling. So here's this interesting thing about things that don't need to be compatible. People sometimes think they should be. Your observation about Brendan Eich had just 10 days to develop it. There is a standard joke that Brendan Eich had 10 days to develop JavaScript, and we're still trying to work out what he did in the second week.
Mm-hmm. So there is Marco who wants to speak and ask you a question.
Oh, hell no, we're not letting Marco speak. Oh, no.
You will listen to what I have to say. I have a question for you. What is, to your knowledge, the best class for date and time management that is most linguistically correct, that gives you the best answers to the questions you can ask? I'm
going to go with, now I'm not going to say I've looked at all the libraries, but I'm going to have to go with probably Noda time, and not just because I know John Skeet. Because he took Yoda time and explored it in much more detail, and he has looked at it from a language point of view, from an API point of view, and he also really understands date and time handling in a way that I have not met in anybody else. It's just, I kind of, on a scale of 1 to John Skeet, I'm probably about a 3 or 4. Okay, and most people I'm going to say are probably lower. John knows a lot about this, but also the API, how it feels, seems to make a lot of sense. So I would say that's probably doesn't mean I'm right. I'm sure somebody else can probably point me in the direction of another one, but that is the most comprehensive in terms of getting all the concepts right, getting the actual implementation details, getting Sweden right, dealing with the Baha'i calendars, and various calendars, including the Baha'i calendar, getting the Hebrew calendar right, all of these things. John has a lot of knowledge in this space.
Thank you.